So we're going to do number 4. You're going to draw the structure for CS2. So I have a carbon and 2 sulfurs. I've given you that you're going to have 2 double bonds this time. So this one's a little different because you don't have single bonds, you have double bonds. The only real difference when you're drawing your structure is you're going to make 2 lines, kind of like an equal sign. I'll show you. You still have to determine the central, and you still have to determine the number of valence. To determine the number of valence, it's always going to be the same steps. It's the same procedure over and over and over and over. So I'm first going to write the elements that I have. So I have a carbon, and I have a sulfur with a subscript of 2. Do not forget to write that subscript down there. I'm going to figure out that carbon is in 4A using my periodic table, and sulfur is in 6A. Remember that the number of valence is equal to the group number, so carbon has 4, sulfur has 6. Multiply both by the subscript. Carbon doesn't have a subscript, so you don't do anything. Sulfur has a subscript of 2, so I'm going to multiply 6 by 2 to get 12. And to get the total, I'm just going to do 4 plus 12 is 16. So the total number of valence is 16. That's how many dots or lines, so total electrons, you have to show in your picture. It's going to be different every single time. Then to do the central, it's closest to carbon. We actually have a carbon. So if you have a carbon atom there, it's always the carbon. The central atom is always carbon if it's present. So now, I got to figure out the most logical, even, nice, balanced way to draw a structure that has 1 carbon in the center, so it's obviously going to be there. And then I want to connect 2 sulfurs with 2 double bonds. The most even way to do that is like this. Put a sulfur here and a sulfur here. That makes more sense than putting it on the top or the bottom. And to represent the double bonds, instead of 1 line, I'm going to draw 2, like an equal sign. So that is a double bond. The way I know it's a double bond is right in the problem on number 4 if you read it. It says number of single bonds 0, number of double bonds 2. So I have 1, 2 double bonds. So I have 1 carbon, 2 sulfur. I have my carbon in the middle. I'm showing 2 double bonds. The only last thing I have to check is 16 total electrons. Even with a double bond, each line represents 2 electrons. So this line is 2. This line is 2. This line is 2. This line is 2. So you have 2, 4, 6, 8 represented. Means I'm still missing 8. I put those 8 in using dots. Where do the dots go? All elements want to have 8 valence electrons. If I look at this carbon right now, because of the double bonds, look, 2, 4, 6, 8. Carbon already has 8. Doesn't want any more. Sulfur, however, both of them have 2, 4. So what I'm going to do is add 4 dots. Now I'm going to do it like this, top and bottom, because remember, even Steven. I want it to be balanced like a seesaw. So if you put dots like that, they're balanced. It's balancing each other out. Then if I count my total number of electrons, I have 2, 4, 6, 8, 10, 12, 14, 16. And we're good to go.